So now let's talk about one of the most important data structures that there is, and it is known as a hash table, hash map, dictionary. In JavaScript, they call it object. It is virtually on every programming language because it has some really interesting features that make it super important. Number one, it is incredibly fast to read and write from it. And it is done thanks to the technology of hashing that when you have, let's say, an array of memory and you have values stored in different parts of this array, the easiest or simplest way to think about this is that hashing, it grabs the input, passes it through a function, and that function is just going to tell us where it's living. So rather than scanning the entire data, let's assume that the data that we're looking for is on the cell that it's in red. And let's say that we're passing the word hello to it. Hello. What it's going to happen is that it's going to perform a math operation that it's going to take it into the location directly. So what this is done is just basically a single operation. This is considered a single operation. So it's, for all intents and purposes, it's an order of magnitude of 1. A single operation is what gives us the address to find the object. So let's see in an array that we have some names like, let's say, the Beatles: John, Paul, George, and Ringo. If we wanted to find Ringo on this array, we would start at the beginning and say, is John Ringo? No. Then we would move to the next one. And we would say, is Paul Ringo? No. Is George Ringo? No. Is Ringo Ringo? Yes. So that took us, in this case, 4 attempts. And 4 equals the number of elements in the array. So because the worst case scenario for us to find an element, it would have to be an order of magnitude of n elements, which is one of the worst possible algorithms, ways to measure the algorithm, that to say that in order for us to find something, we have to do it for everything rather than having a smarter strategy. And for more information on this part, we'll go through it at really deep detail on Java 3. Where we talk about algorithms, how we can use approaches to solving some of the algorithms, dynamic programming, etc. So anyway, so hash tables, because of that, they are a very important tool. So because you have the input and then it points to where the value is, the hash table has a few considerations. One, it's basically a key value pair, a list of key value pairs, where one key is unique and it has to point to a value. Why does it have to be unique? Because it always has to point to the same thing. If it was not unique, it would be really difficult to find the elements on the dictionary. For each key, we have one value. So we can have an object here and an object as a result. So it's a key pair. In here, in the slides, I usually have this dictionary of capitals of the world where you only have one key and one value. The USA being the key, Washington, D.C. being the value, for France being the key, and Paris being the value, the UK being the key, and the value being London. So these elements are not ordered only, so it is explicitly specified by the algorithm, but typically hash tables, dictionaries, hash maps are not ordered, and they have a really fast search, and the keys are unique. You can have multiple cities with the same name, I mean, in this case, but not multiple countries with the same names. So when you are, for example, speaking about countries, if we are in this sample code where we're creating a new hash table, we say that for the key USA, we put Washington, D.C., the key UK, London, etc. When we put 2 entries for Brazil, we're actually overwriting the value. And this is actually what happened in real life also with between Brazil, Rio de Janeiro and Brasilia. Brasilia now is the capital, even though that Rio is still like one of the most world-known cities. But it got overwritten. So in our hash map, this is actually what happened in the history. So for the exercise, there is a file called fear. Even in this slide, it has a day in the life, but for copyright reasons, I cannot put lyrics to the Beatles. So I am putting a public domain element thing, which is the inauguration speech by Franklin Roosevelt. What we're going to build here is that we're going to build a word counter. A word counter is a really important piece of technology. Basically, that's how word vectors, and it's a simple way of saying that Google works. So that is a word counter. So word counter in this case is going to help us identify how many times the word for a day in the life, for example, is used. The exercise here is this to write the algorithm for counting the words. So for example, just to do a quick manual run of what it would look like, the algorithm, and let's go for something highly repetitive. And we are going to put on this side where we're going to be counting the words. This is going to be our dashboard, and we're going to use Justin Bieber baby lyrics. Okay, so this masterpiece starts with O. In our current list in here, do we have the word O? No. Okay, so we're going to use a hash table to store the word O. And we're going to store the count. In this case, because it's the first time that we're seeing it, our hash table now has a value of 1. Then the next one, the word whoa, because it doesn't exist, we put the value 1. Then the word O, does it exist in our hash table? Yes. Okay, what is the value? 1. Okay, well, let's grab that number and increase 1 and store it, because that is going to be the amount of times that this far we have seen the word O. Notice that what I'm doing here is that I'm removing commas and dots and things like that. So that way this whoa won't collide once we get to this one. It will be the same word, just counted for different times. Okay, so then we go into whoa. Whoa. Then is it there? Yes. Give me the value 1. Let's increment 1 and put it back in there. Okay, now it is 2. Now let's go into our well, it is there. Okay. Give me the value 2. Let's increment that and put it there. Put it back into the hash table. Then whoa, we're gonna get the value 2. Let's increment 1, 3, and let's put it back into the hash table. Okay, so now we have that first line word counted. Again, this whoa, even though that this word is different because it has a comma, I'm removing the comma because it is what allows us to do the correct counting. You're going to do the same thing in the exercise. The next thing to discuss is going to be about our final project. And the final project is going to be using the file posted on Canvas on week 5. We are going to create a currency converter. So we are going to grab that list, and we're going to ask 3 questions to the user. This should look something like this. What is the currency you'd like to get? By the way, it doesn't have to have the exact same words. I'm just showing the example. So you would say AUD. Okay, how much? And you can change the order of the questions, use your creativity, and I would say 3,000. Okay, convert to, and I would say MXN just to follow this example. And then you would say, you will get 42,641.40, like something like that. It doesn't have to match exactly this pattern, but this is more or less like what I'm expecting. That you input 2 currencies, an amount, and that's what we're going to calculate for our final project. The use of object-oriented programming will count for 20%. The logical and arithmetic operands are 10%. Data structures like a hash table, list, dictionaries, that all is another 10%. I want to see control flow statements, another 10%. And if it works and it doesn't crash, meaning if I put a fake thing here, it will tell me that currency, or it would handle the fact that it's a non-existing currency. So if it works overall, it's 50, and then I take some points if the program crashes easily or in a way that it should have been reasonably expected. So if there's any questions or anything, just shoot me a message. I'm here for you guys, and yeah, I hope to see your final projects soon. Thank you.